This third question is a difference of perfect squares rule. So I'm going to write up here, difference of perfect squares, or dots they call it. That's when we saw a squared term minus another squared term, which is the difference is the minus part, and the perfect squares are the a squared and b squared. Now we learnt that when you have we learnt when we saw a plus b and a minus b in brackets, we saw that always expanded out to what we see here. So now when we look at this question, when we see 3x plus 7 and 3x minus 7, the same thing, but the signs are different, we know that must have been originally the first term squared minus the second term squared. So if we multiply that out, that would be 9x squared minus 49. So the answer is D. With question 4, all you have to do is just substitute the values into that formula. So if B was -2, so it was -2, and you're going to times it by C, which is -1. So that's that BC expression. Then you're going to minus 3 times A, which is 3. And then you're going to minus B, which is -2. So if we expand that out, so a -2 by -1 is a +2. And -3 times 3 is -9. And then this minus and another minus, that'll become a plus, so we get +2. So we end up, if you group all that, we get -5. So E. Okay, the next couple of questions are going to draw on the other patterns that we learned. So we learned if we have a plus b squared, that would be always expand out to a squared plus 2ab plus b squared. And the other pattern we need to know and learn off by heart is if we have a minus b squared, we see a squared, and this is where it's different, minus 2ab plus b squared. So if we look at question 5, k minus 7 squared is the same as, so we know that expands out. Looking at the pattern, it will be the first term squared minus 2 times k times 7, and then plus 7 squared. So then you fix that up, you get k squared minus 14k plus 49. So we get E. Now with the next question, a square with the side length of x plus 1. So if it's square, means all the sides have the same length, so be x plus 1. And if we think of area of a square, it's always the length squared. So you could say it's x plus 1 times x plus 1, or you could say it's x plus 1 squared. So we have this pattern up here. So if we were expanding that out, it'd be x squared plus 2 times x times 1 plus 1 squared. So that will be x squared plus 2x plus 1. So it's D. Okay. Question 7. If we have 6 less than the product of 9 and x, so if you times 9 and x together, it'd be 9x. And if you have 6 less than it, you'd be taking 6 away. So we would see 9x take 6. So 6. Okay, so we've got 10 more than the sum of the square of x and y. So n's like a plus as well. And so we've got x and y, and we're squaring it, and we've got 10 more. So you'd have 10 more. So you're adding 10 more. So we would see D being the answer. Okay, with question 1 and simplify. You simplify your group like terms. So because -7x and 8x are like term, we can group them. So we get 5 plus 6y, and -7x plus 8x will be plus 1 plus x. Okay, with then these ones, if we're asked to simplify, first we're going to have to multiply the brackets out. So we multiply the 2, anything that's directly outside the brackets gets multiplied with what's in. So that would be 2x minus 6, and then we'll do this one. It would be plus 3x minus 6. So then you could group like terms, which are these are like terms and they are like terms. So you end up with 2x plus 3x is 5x, and negative 6 and another negative 6 equals minus 12. So there's that answer. With this, so the next one, we're grouping like terms, and they are just these two are like terms because the square m squared times n. This one's the squares on the end, so it's not a like term. So we've got 8m squared n plus 8n squared m. These are different, so we can't do anything about it. We'll just leave them like that. Okay, with this last one, 25x squared times y divided by 100xy. Just change it. When you see divided, if we change it to our fraction format and like that, it will make it a lot easier to do, because you can go, there's 1x there and I'll cancel that one. We can cancel the y, and also 25 goes into 25 once and 25 goes into 4. So if we simplify that, we've got 1 and x on the left on the top and 4 on the bottom. So we could just write that as x over 4, but it doesn't matter. I'll accept either. It doesn't matter if you've left the 1 there. Just in a multiple choice in another test, you might have to be aware that it could look like that. Okay, so the next one's asking us to do the same, expand and simplify. So if we times the number directly outside the brackets with what's in, we get 21x, 7 times 3x, and then 7 times negative 6 is minus 42. So there we go. Now with this next one, only the 3 is directly outside the brackets. So let's expand it out first, because we do bod maths, we do brackets first. So we have 4 plus 3x plus 3, because 3 times 1. Now the 4 and the 3 are like terms, so we add them, so we get 7 plus 3x. There's the answer. So with these ones, we're going to keep on doing the same. So we'll multiply out first. So we get 2x plus 6, and then negative 3 times x is negative 3x. Now be careful, negative 3 times negative 2 will be a positive 6. In group like terms, we get negative x plus 12. It doesn't matter if you have 12 minus x. That's as long as the signs in front of the numbers are the same, which it is. Okay, so with the next one, now we've got 2 sets of brackets. We have to remember we times the first term with everything in the next bracket. So we've got x times x, x squared, then x times 7, 7x. Then we have 3 times x, which is 3x, and 3 times 7, which is 21. Tidy it up, it'd be x squared plus 10x plus 21. Okay, and off we go, do the next one, same thing. So 5 times x is 5x squared, 5 times negative 5 is minus 25, and negative 8 times x is negative 8x, and negative 8 times negative 5 is plus 40, so a negative by a negative. So we get 5x squared, oops, I think I've got the x there, minus 33x plus 40. All right, now we've got here, we want to expand this, but this is one of our patterns. So when we saw a minus b squared, we saw that it went to a squared minus 2ab plus b squared. So if I expand that one, it'll be the first term squared minus 2 times the terms inside plus 3 squared. So we square that, that's 25y squared minus 2 times 5 is 10 times 3 is 30. So 30y plus 9 is your answer. Okay, and the last one, you're just going to have to take your time, and it'll be a bit longer, but do it all. Okay, so we're going to be factorising now. So when we factorise, our first step is find the highest common factor. So in this one, it's 8. And then if you like, to begin with, you can write each term with that a multiple of that 8. So 8 times x is 8x, and then if I say 8 times 5, that would be 40. So then what we do is we take out the highest common factor, because it's in both, we put it at the front, and then we put whatever's left into brackets. So you can do this every time if you like, but if you can see the highest common factor and then quickly take it out without having to write it out in multiples, we can do that too. So if we look at these 3 terms, the highest common factor, 3 goes into all of them as well as a. So if I bring 3a out the front, I'd be left with 5b here plus 2cd minus 4d. Now you can check this and by expanding it to see if you go back to the question. So if I go 3a times 5b, it would be 15ab. If I do 3a times 2cd, it'd be plus 6acd. And then if I do 3a times negative 4d, it'd be minus 12ad, which you can see is the question. So I must have done it correctly. Okay, so let's move on to the next one. Highest common factor for these ones is 4 and 1a. So if I take 4a out the front, I'm left with an a and an x, and a minus 4 and a y here. Now this question D is when you factorise, we have a binomial factor. So a binomial, there's 2 bits, a and 7 in there, and it's a factor because it's timesing against that letter a and that negative 3. So remember, we take a common factor out the front, so that's the a plus 7, and we put whatever's left into the other set of brackets. So a is left and negative 3 is left. So that. Now, if you remember in class for this next one, I said generally a good giveaway is when we see 4 terms that we'll be doing the grouping, the 2 by 2. So if you look, there's nothing common about all of them, but if I group it like that, the individual groups have common factors. So this first group has m as a common factor, and I'd be left with x plus 3, and this second group has 2 as a common factor. If I take the 2 out, I'd be left with x plus 3. Then it ends up like one of these. So we got a common binomial factor, which I'll take out the front, and I'll put whatever's left inside the other bracket. So then we've got another one here underneath, there's nothing common about all of them. But if we group them like this, there's still nothing common in those little individual groups. So let's rearrange this around. So if I put the DF there, I'm going to put the minus 6F next because they're common. And then I might put the minus DG, and then I'll put the plus 6G after it. Okay, so I haven't changed anything. I've just moved them around and everything's kept their same sign. So now when I group it, so now common is F here, so I'd be left with D minus 6. Now if I take out minus G, this one would be left with D minus 6 because a negative G times a negative 6 will become back to a plus. And then, surprise, surprise, we have a common binomial factor. So we bring the factor out, which would be like that, and put whatever's left in the brackets. So there's our answer. A lounge room in a house is 7 meters long and 6 meters wide, is to be reduced by X meters in the length and width. Draw a diagram showing the new lounge room. So it was a rectangle and it originally had a length of 7, but we reduced it by X, so minus X. And this originally had a width and we reduced it by that. So these two sides would be the same. So that's also 7 minus X. And this is also 6 minus X. Now write an expression for the perimeter of the new lounge in expanded form. So if you look, why they said it perimeter in expanded form, because we know we have 2 of the lengths plus 2 of the widths, but they don't want you to leave it like that. They want you to expand it out. So you could say 14 minus 2x plus 12 minus 2x. We group the like terms and we end up with 26 minus 4x is a perimeter. Write an expression for the area of the new garden room in expanded form. I think this was supposed to say lounge room. Sorry. So we'll do that. Anyway, so a new area is length times width. So area equals length times width, which we know the length is 7 minus x and the width is 6 minus x. So then we're saying in expanded form, so we will multiply it out. So 7 times 6 is 42. 7 times negative x, negative 7x. Then negative x times 6, negative 6x. And negative x times negative x is plus x squared. So we get 42 minus 13x plus x squared is a formula for the area, an expanded formula. Okay, so the area of a billiards room in square meters is x squared plus 7x. So square meters, just because we measure area in square meters. So we could say the area equals x squared plus 7x. If the width of the room is x, the length of the room what is the length of the room in terms of x? So you did x and you would have times it by the length to get the area. So if you know that x squared plus 7x equaled x times something, we can see to get that pattern we would have had to get another x and plus 7. So you can see because x times x is x squared and x times 7 is 7x. So we can see that this length must be x plus 7 to be able to go back to that area. So what is the perimeter of the billiards room in terms of x? So perimeter, we always have 2 lengths plus 2 widths. So we've got 2 x plus 7s plus 2 x's. So expand that out, it'd be 2x plus 14 plus 2x, which equals, so the perimeter equals 4x plus 14. If x equals 5, what is the area of the building room? So we said area was x squared plus 7x. So every time we see x, we'll put a 5. So area equals 5 squared plus 7 times 5. So 25 plus 35. So the area equals 60 meters squared.